In our previous video, we learned that there is an atom, there is electron particles that are inside the atoms. Now we are focusing on the discovery of protons and neutrons. So we end up with this slide, and we came into the conclusion that if there are some negatively charged particles which are electrons, so there should be something positive in the atom. So let's talk more about what are these positively charged particles and how we discovered them. So Thomson, after figuring out there are some electrons in the atom, so he came up with this plum pudding model, that which is something, or some people call it chocolate chip cookie. At that time, it's seems like plum pudding was more popular at that time. So they came up with the model and they call it plum pudding model. So because they had no idea about the positive charges, so they knew that there is a positive charge in the atom, but their experiments showed that there are some particles that have negative charge. So what they thought at that moment was that atom was a uniform positive sphere, and they have this negatively charged inside this positive sphere. So they had this electron inside the plum pudding or chocolate chip cookie, as the electrons be the chocolate chips, and the whole pudding or the cookie was the positively charged sphere. Before we examine the discovery of the proton, it's better to learn a little bit about radioactivity and know that what is radioactivity and what happens. So radioactivity is spontaneous emission of particles or radiation. Okay, so it just happens spontaneously on some radioactive elements. Okay, and so what happens? So what radiation do we get in the radioactive radiation? So the first one is alpha ray or alpha particles, that we know that they're positively charged particles, and right now we know they're actually helium nucleus. Okay. The second one is beta rays or beta particles, and they are negatively charged particles, and now we know that they're electrons, and they're, as I said, negatively charged. And then the third one, we have gamma ray, which are high energy radiation. They don't have any mass associated with it. They're just like high energy radiation. So if anything have radioactivity, typically one of these three radiation is coming off from the particle. So Rutherford's gold foil experiment was the experiment that ended up in discovering the proton. So one thing we have to know about this is that this experiment disproved Thomson model, the plum pudding model. So Thomson found electron, and the first model came into his mind was that there are some particles negatively charged as electron, and there should be in some positively charged atmosphere, positively charged sphere of atom. With this experiment, Rutherford disproved Thomson's plum pudding model. With this experiment, Rutherford showed that atoms must mostly have empty space, and the positive charge is concentrated in a dense central core, and this dense central core is called nucleus, and the positively charged particles are called protons. So this is the schematic of Rutherford gold foil experiment. So what he did, he had a source here. It was a radioactive source, and this radioactive source was emitting alpha ray. So the alpha ray were hitting this gold foil. Okay, so what happened, most of this radiation just passed through the gold foil and hitting straight and here, and this is a detector. So they had a detector over here. They had some coating, chemical coating, that lit up when they were hit by particles. So what happened, they saw that most of these particles were passing through the gold foil and were hitting right straight from the slit to the back of the gold foil. They also observed that some of the rays were deflected a little bit and hitting close to the center from undeflected. Maybe the non-deflected one is the middle one. Well, it's the same thing. So they had a little deflection and hitting there, and there were some arrays that were deflected a little bit more and hitting there. But what was very interesting, that some of these alpha particles were bouncing off from the gold foil and coming back toward the source. So what did Rutherford said? He thought it was incredible that some of these particles are heading back. The possibility of getting these alpha particles back is just like as possible as if you're firing 15-inch shell at a piece of tissue and it just bounced back towards you. That's how as possible as having the alpha particle bouncing back. So if you look at the plum pudding model, if the plum pudding model was right and we had the alpha particles, they should just pass through the atom and there shouldn't be any problem, and all of the arrays should hit the back of the gold foil. But what happened is, in the nuclear model, that we see that the atom is mainly empty space, and most of these alpha particles are passing through the atom and hitting the back, but you see some of them are deflected a little bit. Why? Because as we know, the proton has the positive charge and alpha rays have also the positive charge, so they deflect each other. So as they're passing close to the nucleus, they are deflected, and since the nucleus is very small, so just some of them are a little bit deflected, and some, only a few of them, that are hitting right on the nucleus, they are bouncing back. Okay, so that shows us that the positive charge in the atom is concentrated on the center of the atom, and the size should be very small because most of the arrays are just passing through, and the charge should be positive as it's deflecting some of the arrays. So about the proton, we know that the mass is this number. It's still pretty small number, but you have to remember that it's 1840 times the mass of electron. Again, you don't need to memorize these numbers, but you have to just think about what is the difference if you can compare the mass of electron and a proton. We know that it has the same size, charge, but opposite sign as the electron, and something about the nucleus, that it occupies that central core in the atom. It occupies 1/10⁻13 the volume of the atom. So if you think about, you usually show atoms like positive nucleus and electrons, but actually this is not really true. So if you think about if I want to show the size of the nucleus as this, I shouldn't be able to draw the size of the atom in this slide. It's very big. It's 1 over 10 to 13. That's a very big number, okay? But that's how we usually show it, because we just want to show something. We cannot draw a dot over here. Even dots might not be the good representation of the size of the nucleus. So Thomson figured out about electron, and with silicon oil drop we find the mass and the charge of the electron. Rutherford discovered the proton and the charge. So what is the next atomic particle? So if you think about hydrogen, at that time it was known that it has one proton, and helium was also known that it has two protons. So let's write hydrogen. It has one proton and it was neutral, so it had one electron. And helium, so it had two protons and two electrons because it was neutral. Okay, so we just learned about the mass of proton, and it's way bigger and heavier than well, not bigger, let's say heavier than electron. So if we are counting for the mass of an atom, it's basically the mass of the proton. So electron has a very little mass that doesn't contribute to the mass of the atom. So if you're comparing hydrogen with helium, the mass should be 1 to 2, because it has one proton in hydrogen and two protons in helium. But what they discovered, so they measured the mass, and the relative mass was instead 1 to 4 instead of 1 to 2. So if it was us at that time and we come up with these findings, what was the logical conclusion with this information? So what they came up with was there should be something in the atom besides the proton and electron which contribute to the mass of the atom. So it should be something neutral, because we know the atom is neutral, and we've learned about electron, about the charge of the electron, about the proton and the charge, and they are equal. So if this particle have any charge, that breaks the balance. So if it has positive charge, then the atom cannot be neutral and it would be positively charged. And if it has negative charge, the atom would be negatively charged. So these particles should be neutral, but they are contributing to the mass. So these were found to exist, and they called it as neutrons. So it took some time, and Chadwick discovered the neutron. We're not going into details of the story how it was discovered, but we just know that they discovered neutron, and they knew that these neutrons, neutrons have no charge, and they have mass. They're contributing to the mass. The mass of the neutron is slightly greater than the proton, so it's almost like proton, it's slightly greater than proton. So if we think about our first example again, so hydrogen atom, they knew that it has one proton and no neutron. So hydrogen, it has one proton, one electron, and zero neutron. Helium atom has two protons and it was neutral, so two electrons. Also it has two neutrons. Okay, so therefore, since in hydrogen the only thing that contributes to the mass is this proton, because you know that electron's mass is very small compared to proton, and it does not contribute to the mass of the atom. So the only particle that contribute to the mass are proton and neutrons. So in helium we have only one proton. Excuse me, in hydrogen we have only one proton. In helium we have two protons and two neutrons. Therefore, the relative mass should be 1 to 4. So the relative mass is 1 to 4. And they discovered that the neutrons were also located in the nucleus. So in the nucleus, in that small place, we have everything that contributes to the mass of the atom, and it consists of protons and neutrons, and electrons is scattered in the empty space around it. So far we learned about atom, and we learned about the discovery of the subatomic particles, about electron, how it's charged. We learned that Thomson did some experiments and found the ratio of charge over mass ratio, and then silicon oil drop experiments helped them to find the exact charge and the mass of the electron. Rutherford experiment discovered proton, and then later on with Chadwick experiments they discovered about neutron, and they learned that all of them are, both proton and neutrons are in the nucleus of the atom.